Welcome to GDP's Animation 2020. My name is Felipe Bellini and this is a video demonstration for Project 1, addressing the classes lectured by Michael Finney at Fanshawe College. Project 1 is about skinned mesh animations. In this solution, we should see two main characters that are animated using the vertex shader, and also they are controlled by the user. Each user input triggers a different animation on the characters, while also causing the characters to dislocate in 3D space. So this is our OpenGL scene. We can use the camera to get close to our characters. So we have two characters, a skeleton and what was called a peanut man, because it's shaped like a peanut. So if we are to control both characters, we have to press F1, so the mouse is released from the game, and then we can use the graphical user interface to select either of the characters. You can see them turning red as I select them using the graphical user interface. Then I need to press F1 again to go back to the game. Now all the controls are bound to the character except for the mouse. So we can see some animations when I move the character back and forwards. We can do some strafing. I'm using the WASD keys. We can also jump. We can also trigger an action, which is a headbutt. Again. After the animation completes, the character always goes back to idle, no matter what. Also, you can turn the character using the arrow left and arrow right. Also, when you're turning the character, it will move in the relative direction it's facing. So you can press to turn and then move in the relative direction. This is just me turning and then pressing W. So another thing that's happening in this scene is that the physics system is active in the game, so we can see the rigid bodies around the characters. So there are two spheres, one for each character. So if I move one character towards the other one, the character will bounce against the other one. So if I keep moving towards the skeleton, I will be forcing the skeleton to bounce and go in the other direction. As you can see, it's like the shapes are colliding. So it's behaving like properly against the environment. So the skeleton should bounce off the glass. Another thing here that was mentioned in the project scope was that we should be able to strafe in the direction we're facing. So if you take a look, now I'm strafing and I'm turning towards the camera. Now I'm strafing again. And observe that strafe follows the forward of the character, no matter what happens. So I will restart the game so we can also move the skeleton and see the skeleton animations. Okay, so now we're back to see the skeleton animations. I'm going to use the same alternative here, using the graphical user interface. So now I can move the skeleton around, I can turn left and right, I can jump, and also I can attack pressing F, so it can punch the enemy. As the character is moving, it's dislocating in 3D space, so you can see the rigid body following the character. As as the skeleton moves, you can see. Notice how it moonwalks. Okay, great. Another aspect of this project is that there are specific animations for rolling and running, so we can do that as well. I'm going to select one of the characters here, and we're going to press Shift to have a sort of an alternate mode here. So turning the skeleton around. Now this is walking, right? So if you press Shift and W, the skeleton will run. And if you press Shift plus A or D, it will, instead of strafing, it will roll. Same thing for the Peanut Man. I can run. Oh, sorry. I can run. Notice how the animation is different if it's going forward, and if it's running, it's kind of desperate with the arms hanging around. And then you can roll, pressing Shift and D now. It's rolling, rolling, rolling. Okay, great. The main aspects of this project can be found in the game here. There's a class called Animation Project. There's a bunch of things here, like the logic used for idling the character as a sort of a trigger for what the character is supposed to do here, the action it takes. So if it's walking backwards, then moving relative direction and triggering the walk backwards animation and so forth. That's one interesting point here of this project. So that concludes our presentation. For more information, contact Michael Finney or Felipe Bellini at Fanshawe College. Thank you.